4. Testing arguments in sentential logic. In the previous section, we noted that an argument is valid if and only if there is no case in which the premises are true and the conclusion is false. We also noted that the cases in sentential logic are the possible combinations of truth values that can be assigned to the atomic formulas letters in an argument. In the present section, we use these ideas to test sentential argument forms for validity and invalidity. The first thing we do is adopt a new method of displaying argument forms. Our present method is to display arguments in vertical lists, where the conclusion is at the bottom. In combination with truth tables, this is inconvenient, so we will henceforth write argument forms in horizontal lists. For example, the argument forms from earlier may be displayed as follows. A1 PQ, Q/PA2 PQ, QRPR and a1 and a 2, the premises are separated by a semicolon. And the conclusion is marked of by a //. If there are 3 premises, then they are separated by 2 semicolons. If there are 4 premises, then they are separated by 3 semicolons, etc. Using our new method of displaying argument forms, we can form multiple truth tables. Basically, a multiple truth table is a collection of truth tables that all use the same guide table. This may be illustrated in reference to argument form A1. Guide table argument PQ Q/P case 1 TTTTTFTFT case 2 TFTFFTFFT case 3 FTFTTFTTF case 4 FFFTFTFTF. In the above table, the 3 formulas of the argument are written side by side, and their truth tables are placed beneath them. In each case, the final output column is shaded. Notice the following. If we were going to construct the truth table for Q by itself, then there would only be 2 cases to consider. But in relation to the whole collection of formulas, in which there are 2 atomic formulas P and Q, there are 4 cases to consider in all. This is a property of multiple truth tables that makes them different from individual truth tables. Nevertheless, we can look at a multiple truth table simply as a set of several truth tables all put together. So in the above case, there are 3 truth tables, 1 for each formula, which all use the same guide table. The above collection of formulas is not merely a collection. It is also an argument form. So we can ask whether it is valid or invalid. According to our definition, an argument is valid if and only if there is no case in which the premises are all true but the conclusion is false. Let's examine the above multiple truth table to see whether there are any cases in which the premises are both true and the conclusion is false. The shaded columns are the only columns of interest at this point, so we simply extract them to form the following table. PQ Q/P case 1 TTTFF case 2 TFFTF case 3 FTTFT case 4 FFTTT. In cases 1 through 3, one of the premises is false, so they won't do. In case 4, both the premises are true, but the conclusion is also true, so this case won't do either. Thus, there is no case in which the premises are all true and the conclusion is false. To state things equivalently, every case in which the premises are all true is also a case in which the conclusion is true. On the basis of this, we conclude that argument A1 is valid. Whereas argument A1 is valid, the following similar-looking argument form is not valid. A3PQP/Q. The following is a concrete argument with this form. C3. If Bush is president, then the president is a U.S. citizen. Bush is not president. The president is not a U.S. citizen. Observe that C3 is the form of 3, that C3 has all true premises, that C3 has a false conclusion. In other words, C3 is a counterexample to A3. Indeed, C3 is a counterexample to any argument with the same form. It follows that A3 is not valid. It is invalid. This is one way to show that A3 is invalid. We can also show that it is invalid using truth tables. To show that A3 is invalid, we show that there is a case line in which the premises are both true but the conclusion is false. The following is the multiple truth table for argument A3. PQ P/Q case 1 TTTTFTFT case 2 TFTFFFTTF case 3 FTFTTTFFT case 4 FFFTFTFTF. In deciding whether the argument form is valid or invalid, we look for a case in which the premises are all true and the conclusion is false. In the above truth table, cases 1 and 2 do not fill the bill, since the premises are not both true. In case 4, the premises are both true, but the conclusion is also true, so case 4 doesn't fill the bill either. On the other hand, in case 3 the premises are both true, and the conclusion is false. Thus, there is a case in which the premises are all true and the conclusion is false, namely, the third case. On this basis, we conclude that argument A3 is invalid. Note carefully that case 3 in the above truth table demonstrates that argument A3 is invalid. One case is all that is needed to show invalidity. But this is not to say that the argument is valid in the other 3 cases. This does not make any sense, for the notions of validity and invalidity do not apply to the individual cases, but to all the cases taken all together. Having considered a couple of simple examples, let us now examine a couple of examples that are somewhat more complicated. PQ QP/P and Q1 TTTTF TTTF TTTTTTTT2 TFTF FTFFF TTFF TTTF 3 FTF TTF TTTF TTTF FFF T4 FFF TTF TFTF FFF TFFFF. In this example, the argument has 3 premises, but it only involves 2 atomic formulas P, Q. So there are 4 cases to consider. What we are looking for is at least one case in which the premises are all true and the conclusion is false. As usual, the final output columns are shaded, and these are the only columns that interest us. If we extract them from the above table, we obtain the following. PQ QP/P and Q1 TTTTT2 TFF TTF 3 FTTTF F4 FFTFTF. In case 1, the premises are all true, but so is the conclusion. In each of the remaining cases 2-4, the conclusion is false, but in each of these cases, at least one premise is also false. Thus, there is no case in which the premises are all true and the conclusion is false. From this we conclude that the argument is valid. The final example we consider is an argument that involves 3 atomic formulas letters. There are accordingly 8 cases to consider, not just 4 as in previous examples. PQR PQR PR/Q and R1 TTTTTTTTFF TTTFF T2 TTF TTTFF TTTFF TTTF 3 TF TTTF TTTFF TTFFF T4 TFF TTF TF TTTF TFF TF5 F TTF TTTF TF TTTFF T6 FT FFF TFFF TTFF TTTF7 FFTF TF TTF TF TTFFF T8 FFFF TF TFF TTF TFF TF. As usual, the shaded columns are the ones that we are interested in as far as deciding the validity or invalidity of this argument. We are looking for a case in which the premises are all true and the conclusion is false. So in particular, we are looking for a case in which the conclusion is false. There are only 2 such cases, case 2 and case 6. The remaining question is whether the premise is both true in either of these cases. In case 6, the first premise is false, but in case 2, the premises are both true. This is exactly what we are looking for, a case with all true premises and a false conclusion. Since such a case exists, as shown by the above truth table, we conclude that the argument is invalid.